All right, hello again. So in this video, we're going to talk about what can go wrong with programming and how we can deal with errors. So errors will always occur when programming. No one, and I mean no one, writes perfect code the first time. And the only reason you're not seeing me mess up even more than I already am is because these videos were pre-recording and I'm trying to edit out some of my screw-ups in order to save you some time. All right, so let's get into it. All right, so here's our first example. This is our hello world example from a previous video, and this code has an error. Can you see what the problem is? As a hint, try looking at the closing parenthesis and see if you can notice what the color might be. Okay, so what happens if we go ahead and we actually execute this code, right? We're going to hit Shift and Enter, and we execute the code, and we don't see our friendly greeting message, but instead we see this kind of mess. So this is an example of an error, which in computer programming is often commonly referred to as a bug. They're called bugs because of historical reasons. So back in the very early computer days, so this is in like the 1940s, when machines were large enough that they fill up an entire room, Admiral Grace Hopper was trying to track down the source of an error in one of these machines. And the error, the cause of the problem, was literally a dead moth inside of one of the giant vacuum tubes that was running this entire machine. So she takes the moth out, tapes it to like the log book indicating that this was the error, and so that was literally the first computer bug, and now all computer errors are referred to as bugs. So your task is going to be to remove the errors, to actually debug the code, to try to get rid of all the bugs in your code so that it works well and everything's correct. All right, so let's go back to our error. Let's look really carefully at this particular error and see what exactly the Python interpreter tells us. So first, if we start sort of at the bottom of this output, the Python will tell us the kind of error that we got. So this is an example of a syntax error. A syntax error means that we made a mistake in how we actually used the Python language. Our words or our grammar were incorrect, so that our interpreter couldn't even begin to make sense of what we said. We were basically speaking gibberish to the interpreter, and so it got confused, and then that caused an error. That made a bug. The interpreter, when it sees a syntax error, will try to tell us what was wrong with the syntax. This is the error message. And that's sort of the next piece of text that comes after that. This won't necessarily tell us what mistake we made. Computers aren't that bright. They're not able to actually figure out what mistake we made, because if so, they would just fix it. But instead, they're going to tell us where it got confused and then why it got confused. Effectively, what it thinks was going wrong. So in this case, the error message that we get says EOL while scanning string literal. So this is fairly opaque. It's actually difficult to understand. So things that you can sort of learn if you hang around these things long enough. EOL is short for end of line. So the interpreter is telling us that it was scanning through, it was reading a literal string, right? So this is actually a string written out with quotes, not a variable string, but it got to the end of the line before it got to the end of the string. So it got lost. It's like I was trying to read a string, but then like I suddenly ran out of string and I don't know what was happening. I got confused and I'm going to then crash and have a bug and say that something's wrong. Well, so the question is, how do we then fix that? Well, we want to make sure that we end the string before the line finishes. And if we then look, say, okay, well, that was the problem. It got stuck trying to read the string. So we look back at our string and we say, oh, look, it was missing this closing quote. Look, that makes my final parenthesis turn green again so that life feels a little better. So when we add that back in and we go back and rerun our code a second time, we can then see that now we get our message, our code works, we zap the bug, our program is fixed, everything's good. So not all error messages are as opaque as the end of line error. So for example, here's an error where we tried to print out hello world, but we forgot to include the parentheses. So if we go ahead and we run this line of code, you'll see we're once again getting an error, but it's going to tell us, which it says is a syntax error, but now it actually gives us something fairly useful. It says missing parentheses and call to print. Did you mean print parenthesis hello world? It actually gives us a suggestion on how we might fix this problem. Python is helpful about this particular bug because using print without parentheses is actually the proper syntax. That was a correct way of writing code back in Python 2. So the interpreter actually has notes inside of it to make sure that if someone tries writing Python 2 code in Python 3, that it will sort of tell them how to fix that one piece. So that's a good thing actually to remember, that if you find some code that has a print statement without parentheses around it, that means you're looking at a Python 2 example, which has got old syntax and it's probably not going to work out very well for you. Okay, so back to error messages. Because Python code code blocks can actually contain a lot of lines, the error message will actually include the line number and the location of the error, or at least the location where the interpreter got confused and thought there was an error. So for example, here's another example of a block of code, but we've got now multiple different print statements. So we've actually got lots of lines of code, and we have the same kind of error, right? We got the same syntax error, end of line while scanning string literal, and it'll actually then tell us where that problem is. So it'll show us what line of code it had the problem, saying exactly what character, what point the interpreter got confused, and if we look up a little bit further, it'll tell us what line number that was. So if you want to actually count down from the bottom, you can count down 1, 2, 3, 4 lines, and then figure at line 4, at that one, that's where it found the end of line while scanning a string literal. That's where it had the problem, so that it'll actually give us some information, tells us where we should go to be able to find that error. And that's really, in many ways, the tricky part, is figuring out that once the interpreter says, here's the error, is actually figuring out what that error is, where it is, and then figure out how we can fix it, right? So I want to be able to add in my parenthesis, and then be able to run my code and be able to make things work again. So the bugs that we've looked at so far were examples of syntax errors, but there are other kinds of errors that we'll actually get as well. So here's another example of an admittedly fairly contrived example, but at least will show off what I'm trying to demonstrate. So in this code, we're going to assign 150 to earnings in dollars. We're going to assign a 0 to hours worked, and then we'll assign a pay rate, which is earnings in dollars divided by hours worked. So if I go ahead and I execute this code with Shift Enter again, then I'm going to get another error message. This looks somewhat similar. There's just a little bit more words, which is part of why it goes more crazy. So in this case, instead of specifying we have a syntax error, it says that we have a 0 division error. Error division by 0, which hopefully is at least kind of self-explanatory, right? You can't actually divide by 0. This is an example of a logical error. So a logical error is not necessarily a problem with how we wrote the code, but it's what we told the code, a problem with what we told the code to do. So the interpreter understood exactly what we said. We just said something that wasn't sensible. It's not that we said gibberish, it's just that we gave something, so we said to do something silly. So in this case, we gave really clear instructions. We told the interpreter, take these two values and divide them. That makes sense. The interpreter understood exactly what we told to do. It's just that one of the thing we told to do was not a good idea, right? Because you can't actually divide by 0. So what we did is we gave them very clearly stated directions that were very bad directions. So it's an example of a logical error. The main point here is that the line where the error got reported, right? So it says that it has an error right here at line 3. That's where the error occurred, but that's not actually where the problem is, right? Our error isn't that we tried to divide by hours worked. The problem is that our hours worked is 0, right? The division is okay. That's how we would calculate pay rate, but we're dividing by a bad value. So the mistake we made, the problem actually is that we have a 0 here instead of something else. Like maybe I meant to put 10 and like my finger slipped and I forgot the 1. So when you're looking at logical errors, often the reported problem is not actually where the problem is. That's saying that's where the interpreter got confused. The problem, the place you need to make the fix is actually maybe going to be a couple lines further up, or maybe even many lines further up. So you can't just look at the indicated line and say, that's my problem. You have to actually consider all of the code you wrote. A good step is to sort of work your way backwards to try to look to see where the error is. All right, so here's another example of a common logical error. So again, we ran this block of code. Earnings in dollars equal to 150, hours worked is equal to 10, fix that issue. Pay rate is equal to earnings divided by hours. I ran this code, and I got this logical error, a name error. Name earnings is not defined. So think about it for a second, right? What does this error message mean? What might be its cause? Right, that's exactly right. So the error that's telling us is that it has a variable earnings that hasn't been defined. We're trying to use a name tag earnings, but that name tag doesn't exist. So Python doesn't know what we're talking about when I say the word earnings. So if I go back and I look to see what my code was, and again, the problem isn't in my pay rate as earnings per hours necessarily, but the error is that I tried using the word earnings when really my variable's name was earnings in dollars. So I'd actually used a much longer description when I originally declared the variable, but when I tried to sort of go faster and I forgot something, I ended up causing a problem and screwing something up. So this can of course be fixed just by making sure that our variable names match. So if I change this to be earnings in dollars and I change this to be hours worked, then now my code will work. I'll actually print out the pay rate so you can see that it works. right? I can actually do this kind of work once I fix that error, but again, we have to figure out where that is in order to, we have to be able to interpret that error in order to be able to fix it out and understand how to make it work again. Yeah, this is also a good way to make sure that you're sort of being very careful about your variable names, because that's a kind of error that happens a lot, and so we want to be able to fix those kind of issues. This kind of problem becomes even worse if we had just named these variables A, B, and C, and we had A, B, C is equal to B divided by A, because then when the interpreter says that I don't know what you mean, but there is no variable F defined, we have no idea what term necessarily we want to use in its place. So this is why we want to make sure that we're giving clean and consistent variable names as we're writing up our code. All right, so this is this is an example of the last kind of error that we're going to talk about today. So again, looking at this code, do you see a problem? All right, I'm going to try running it. We'll see what happens. It printed, right? We didn't get an error message, but is it correct? No. So this is an example of what's called a semantic error. So the code we wrote is understandable. The interpreter figured out what we were trying to say. It ran perfectly. We didn't try to do anything silly like divide by 0 or use variables that don't exist. But the program didn't actually do what we wanted it to do. Right? We wanted to print out hello world, but it didn't. It printed out hello world, and that's not what we're expecting. This is in many ways the hardest kind of bug to both identify and to actually address, because we need to very clearly understand what we wanted to happen and then be able to figure out with what actually happened was what we expected or not. Effectively, we need to be clear about what our inputs are and what our outputs are. So the best way to catch these kinds of semantic errors is to be able to frame your programming in what I call expect statements. An expect statement is going to be a sentence of the form, when I do X, I expect the result Y. When I run the code, I expect it to print hello world. When I calculate my pay rate, I expect my pay rate to be above $15 an hour. You can write down these kinds of statements like in a comment, right? So I could be able to say that, write down some code, right? I expect this to print hello world. And if I write that down, then I know what I'm looking for when the code should be run, so that if the code does get run and it doesn't match my expectations, then I know that I have some kind of problem. Then we need to figure out what that problem might be. Often that problem is going to mean that my approach to solving the problem, right, what the code I was trying to write isn't actually doing the correct thing. It's not that I wrote the code wrong, it's that my approach to my algorithm was sort of overall incorrect. And I need to go back and revisit that and figure out maybe what might have happened there. So the base idea is to be able to not necessarily, you don't have to write this for every line of code you ever write, but being able to think in sort of large brushstrokes about how your program is, what you expect your program to be able to do. Not necessarily what you need it to do at the end, but what you're expecting a certain set of code to actually happen when you execute that, and being able to write that down so that when something works or doesn't work, something runs, you're able to see whether it worked or doesn't work against those specs. Yeah. Good. So in general, having a sense of here's what I expect the answer to be is actually incredibly important when you're doing programming, particularly if you're trying to do data science-based programming. I'm often going to tell students that when they're writing their code, they should be doing sanity checks on their work. Right? They want to make sure that the data results that they got falls within some kind of expected range. Or if I'm calculating my pay rate, I want to make sure that I should have a sense for what the answer should probably be, even if I don't actually know what the answer is going to be yet. Because that way, when whatever answer I get, I can understand whether I feel like I might be totally off base or whether there might be something small going on. This becomes incredibly vital as your code becomes more complicated, to the point where you can't just do the work in your head, so you need the computer to do these calculations and do this work for you. You need to have a sense for whether it's going to be getting you towards the right answer or not. And it becomes even more important if you want to start moving towards things like machine learning algorithms, sort of advanced data science-y kind of work, where you have no idea what the computer's actually doing at all. It's just giving you some answer at the end. You need to have, again, some sense for what you think the answer is probably going to be, so that you can know whether it seems like you might be on the right track or not. And then if it's not the same as you expect, you can begin investigating why that might be the case. Okay, so that's a summary of the kinds of errors you're going to encounter while programming. Will be syntax errors, logical errors, and semantic errors. And you will encounter errors. Nobody writes perfect code the first time. Everybody makes mistakes. Programming, even for professional programmers, is really just the process of making a whole bunch of mistakes and then identifying and fixing those mistakes. The act of programming is really the act of debugging. So when we say I am programming, what we really mean is I am debugging a program. So that's what the skill we need to be able to have, is figuring out how to read and understand these error messages and then be able to fix these kinds of bugs. In the next video, we'll go over some of these strategies we might use to be able to fix some of these kinds of mistakes.